This is a second example of balancing redox reactions using the half-reaction method. So again, on this first slide, I have the steps that we're going to take. And you can also find these posted on Desire to Learn. All right, so we're going to follow the same procedure that we did in the last example. This one's just going to have a couple of wrinkles that we didn't have to deal with in the previous example. So the first thing I need to do again is assign oxidation states to everything. And so if you want some help with this, I encourage you to go back and look at my video on assigning oxidation states. But in this first molecule, chromium is going to be +6, the oxygen -2. Here the nitrogen is +2, oxygen again -2. Chromium here is obviously +3. Then I have a +5 for the nitrogen and a -2 for the oxygen. And so I need to split this into my reduction and oxidation half reactions. And so the element that was reduced was chromium. So it's going from +6 to +3. So its charge was reduced. So that's how I know that it was the one that's being reduced. So my reduction half reaction will be the following. And the species that was oxidized is the nitrogen. Nitrogen went from +2 to +5. So my oxidation half reaction will be all right, so let's deal with the chromium reaction first. The first thing I need to do is balance everything that's not hydrogen and oxygen. In that case, it's chromium. I have 2 chromiums on the reactant side, just 1 on the products. So to balance the chromium, I need a 2 here. My next step is to balance the oxygens by adding waters. So I've got 7 oxygens on the reactant side, none on the product side. So I'm going to need to add 7 H2Os to the products. And then finally, I'll balance the hydrogens by adding H+. So I have 14 H+ on the product side, none on the reactants. So I'm going to need to add 14 H+ to the reactants. And the last thing I need to do to balance this reaction is the charges. So my total charge right now on the reactant side is +14 -2, so that adds up to be +12. And on the product side, I have 2 times +3, so that's going to be +6. So remember that electrons are negative, so I want to add them to the side that is the most positive. And so I have +12. I need to get that down to +6. So I'm going to need to add 6 electrons to the reactant side. All right, now we'll follow those same steps for the oxidation half reaction. So the nitrogens are balanced. So my next step is oxygens. I've got 3 and 1. So I need 2 waters on the reactant side. I'll now do the hydrogens. So I've got 2 times 2 is 4 and 0, so I need 4 H+s. On the right. And now I'll balance the charges by adding electrons. So my total charge on the reactant side, they're both neutral, so I have 0. On the product side, I have +4 -1. So that's going to leave me with +3. So I need to add 3 electrons onto the product side. All right, my next step is going to be to add these 2 half reactions together, and I'm going to do that on the next slide. All right, so I've just retyped the half reactions that we balanced in the previous slide. Now, when I add these together, remember that the number of electrons on the reactant side of the reduction half reaction has to be the same as the number of electrons on the product side in the oxidation half reaction when I add these guys together, because ultimately I want the electrons to cancel out. And so the lowest common product of 6 and 3 is obviously 6. So I can leave the top one alone, but I need to multiply the second one by 2. All right, and so now I'll collect all of my reactants from the two half reactions, and then all of the products I'll collect on the product side, and let's see what I end up with. So I'll have from the first one, all right, don't forget, so I want to go to the second one, got to multiply these guys by 2. So that'll give me 4 waters and 2 NO. Now I'll do the same thing. I'll collect my products. I'm just going to write it down on another line to be sure I have enough room. So for my products, okay, so now anything that appears on both sides I can cancel out. So obviously my electrons, I've got 6 and 6, and so they will cancel out as they need to. Now I also can cancel out some of the H pluses. So I have 8 H plus on the products, I have 14 H plus on the reactants, so these 8 will go away. I'll lose 8 of these, so 14 minus 8 will leave me with 6 H plus, and I notice that I can also cancel out the water. So I've got 4 waters and 7, so these 4 will go away. I'll lose 4 of those, leaving me with 3, and that's all that I can cancel out. And it's typically the electrons, the H pluses, and the waters that we want to be most aware that we may be able to cancel out. So what that leaves me with is the following. Okay, and at this point, if I've done everything correctly, my redox reaction should be balanced, but it's always good to double check and make sure that both the atoms are equal on both sides as well as the charges. So I have 6 hydrogens, 2 times 3, I've got 6 hydrogens on the product side, 2 chromiums, 2 chromiums, I have 7, 8, 9 oxygens, I've got 3 plus 6 oxygens, so I've got 9, and 2 nitrogens, and 2 nitrogens. And when I look at the total charges, I've got positive 6 minus 2, that's going to leave me with plus 4. And then here I have 2 times 3 is going to be positive 6, but then minus 2, so I've got plus 4. So both the charges and the numbers of atoms are balanced. So my redox reaction has been successfully balanced.